Welcome to the first of a two-part series on forge welding. So your tool of choice is a hammer, and you need to know the principles behind hammer penetration, which will help guide us on how to make sure you're setting yourself up for a successful weld. First, let's talk about the type of metal. In this case, we're going to use mild steel. Mild steel is a little squishier than other metals such as tool steel that has a higher carbon content. The next factor is the strength of the blow. A lot of people think that you really got to hit your metal hard in order to weld it. In fact, that is the opposite of the truth, in that a hard, heavy blow is only going to deform your material or forge it and not weld. So you want to use light to moderate blows. The third factor is how hot you get your metal. Metal will weld in a range. You want to give yourself the best case possible, and that is weld in the high end of the welding range, which is your bright orange to yellow heat. And finally, we get to the location of the blow. The location of the blow is going to lead us into a discussion about why we form a scarf. If you wanted to weld these two bars together, you would need to hit them from the side. If you had two bars positioned one over the other, like this setup for a lap weld, you'd want to hit them from this direction or this direction in order to weld here. This is the welding plane. And what this is showing us in this welding plane and this welding plane is that the blows need to come perpendicular to that plane. So this is a graphic representation of what's happening in this plane right here. When the hammer blows come perpendicular-ish to this plane, you're welding. When the hammer blows come from a parallel field, such as this side or this side, or even top down in this picture, you're creating a shear plane where these two pieces of metal are going to slip past each other. So let's put these four factors together with what we know about how metal behaves and review how we can outsmart the metal by creating something called a scarf. We want these pieces to blend in, and we want them to blend in such a way that the final weld is the same as your parent stock. So looking at these two pieces lined up, you can see that not all these edges that are going to be pushed down into the other piece of metal are lined up in the welding plane. In fact, these are parallel to your hammer blows and become a shearing plane. To me, these sharp ends look like a chisel, and indeed that's exactly how they act. They will push down into the metal, creating a crack that you cannot blend in. So to get ahead of that, you simply create a slope that is more in line with the welding plane. And that's why I always say perpendicular-ish to the welding plane. You want this to blend in nicely, and with this configuration, that's exactly what will happen. The next factor to consider is what happens to this metal when you hit it from on top. Anytime you hit metal, you know that it's going to widen and lengthen or stretch. When we have one piece of metal on top of the other, nothing's changed. In fact, this bottom bar isn't going to move at all and will act like an extension of your anvil, which means we need to do something about that spreading to avoid making little flaps or wings that will form on either side of this that you won't be able to blend in later. The simplest thing to do is to thin that top bar from the top down view, so thinning from the sides, so that it has room to grow on either side over the top of the bottom bar, which is just acting like an extension of your anvil. So let's try our first weld by creating a situation where you have a thin bar of material, but you're going to double it so that you have material to spread out to, in this case, a flux spoon. The material will be stacked and ready to weld straight out of the fire. And we're going to need to set that up by thinning the toe, creating the taper, bending it over the top of itself, and then welding it. Applying all the principles I just discussed, you're going to create a 3-sided taper at the end of a 3/8 round bar, then bend over the tip. This material will add to the amount of material available to you. You will weld it and then spread it into the shape of a round disc to become a spoon. Here are the steps to weld. The metal must be clean to weld. To obtain a clean surface, you're going to want to brush and flux your piece, as the flux is a corrosive that will dissolve the scale that forms while you're heating the piece. That scale will interfere with the weld. It also applies a protective coating to prevent more scale from forming. You want to heat first and apply the flux hot, as the longer the flux stays in the fire, the less useful it becomes. So heat to a welding temperature, brush and flux, and then bring it back up to a welding temperature. You're ready to weld. You have your piece heated, fluxed, and reheated. So you're going to hit the top, and then you're going to move to the toe by angling your hammer as quickly as possible. The goal will be to blend this toe in with that first heat. Turn it over if you still have a welding temperature, or right back in the fire. Here is a piece heated to welding temperature. You've got your yellow, bright orange. You're going to hit the top with your light to moderate blow, angle your hammer, and with even lighter hits, blend in that toe using good hammer control so that you don't end up thinning the parent bar. Turn that over as long as you have a welding heat, and do the same on the other side. The splash that you see here in this picture is the flux and debris coming out of that initial weld. And you're not always going to see a spray like this, but it does show you that that flux acted a bit like a lubricant and got rid of any material in there that was creating a dirty surface. Continue to spread your spoon. And as you do this, you're going to want to keep this at that welding heat, especially for the second, third heat after you've initially stuck your weld. If you work this too cold, there's a good chance that that weld will fail. Here's a photo that shows a wing that developed by not turning the piece and working one side too long. It's very difficult at this point to get that to blend in correctly. So the best plan is to avoid it and turn your piece often. So here's your completed weld, and your spoon is ready to dish. However, these principles could apply to any other element you might want to make that would start on smaller stock, but you need more material at the end to give it a fuller look, such as a leaf. So you could maybe try out this weld on some other things. In fact, when you are ready to try this, I would recommend that you scarf and bend several bars. Try welding at different ranges, and when it starts to stick, that's the color you should use. Doing one after another will help you see the color and gain confidence in that skill, confidence and experience. This is the end of part 1 of a 2-part series on forge welding. You can either go on to the second part right now or try this and then move on to part 2.